Hey mathematicians, it's Justin again. I'm just cleaning up after the party. Everyone loved the decorations you helped me with. Uh-oh. Looks like during the party, one of the guests got a stain on my tablecloth. Let me go get something to clean this up. I'll be right back. All right, let me just use this stain remover, and we'll get right to the left. Oh! Oh no. Oh no. It's spreading. Oh, that's not good. Well, I accidentally made the stain bigger. Much bigger. Do you think we could figure out how much bigger the stain got?
The original stain had dimensions of 3 units by 4 units, and the new stain has dimensions of 12 units and 9 units. So let's compare these. I know the scale factor going from this smaller figure to the larger figure is greater than 1 since it got bigger, but what is the scale factor exactly? We could go from 3 to 12 using a scale factor of 4, but to get from 4 to 9, multiplying by 4 doesn't work. We know the scale factor has to be the same for all the matching sides, so why isn't that happening with the sides we're using? Yeah, the figure's orientation changed. It was rotated or turned, so before we can calculate the scale factor, we have to find the sides that correspond to each other. Corresponding sides are pairs of sides located in the same position on two figures. Take these triangles, for example. These two sides of the triangles are corresponding because they're in the same position on the two triangles. And no matter how the triangles are oriented or turned, those two sides are still corresponding to each other. So, which dimensions on our rectangular shaped figures go together or correspond? The long side of the original figure was this 4 units at the bottom. But with the scaled figure being rotated, the longer side wound up here as 12 units. And this shorter side that was 3 units on the original figure ended up here at the bottom of the new figure and is now 9 units. Now that we know which sides go together, we can figure out the scale factor. What scale factor can we multiply by to get from 4 to 12 and from 3 to 9? Yeah, the scale factor is 3. Check out these triangles next. What do you notice that we haven't seen before in this unit? Something I noticed are the words pre-image and image. What do you think pre-image means? Pre means before, so the pre-image must be the original figure before it's scaled. And the image is the figure after it's scaled. Pause the video now so you can jot these definitions down in a way that'll help you remember them. What else do you notice about these figures? These figures have labels for their angles. This can help us figure out which parts of each figure are corresponding. For example, side AB is the side between A and B. It's here on the pre-image, and it corresponds with side AB on the image. What other sides are corresponding? Yeah, side AC in the pre-image corresponds to side AC in the image, and side BC corresponds to side BC. Now that we understand what's here so far, let's take a look at some side measurements. Which of these side measurements can help us calculate the scale factor from the pre-image to the image? Remember that we need to know the measurements of 2 corresponding sides to calculate the scale factor. Pause the video now and see if you can figure this out. Ooh, we only know the length of side AB on the image. We don't know AB on the pre-image. And we only know the length of side AC on the pre-image, not the image. But we do know the length of side BC on both the pre-image and the image. Since BC on the pre-image corresponds to BC on the image, we can use their lengths to find the scale factor. What scale factor will take us from 25 units to 5 units? The scale factor is 1/5 because 25 times 1/5 equals 5. Now that we know the scale factor, we can figure out the missing dimensions. Go ahead and use what you know about scale factor to find the length of side AC on the image. Pause the video and try this now. We can use the scale factor and multiply it by the known length on the pre-image. 15 times 1/5 gives us 3 as the length of AC on the image. And what about the length of side AB on the pre-image? Can we multiply by 1/5 to get that length too? 4 times 1/5 is equal to 0.8, but the pre-image sides in this example are supposed to be bigger than their corresponding sides on the image. 0.8 is smaller than 4. Why do you think our scale factor isn't working here? We can multiply by the scale factor to calculate side lengths from the pre-image to the image. But we're trying to go backward from the image to the pre-image. If we want to undo multiplication by 1/5, how do you think we can do that mathematically? Since division and multiplication are inverse operations, let's try dividing by the scale factor of 1/5. All right. We'll take 4 divided by 1/5, and instead of dividing by a fraction, we can multiply by the reciprocal. The reciprocal of 1/5 is 5/1, so we have 4 times 5, which is 20. So side AB on the pre-image is 20 units. And we got this by dividing by the scale factor, which is the same as multiplying by the reciprocal of the scale factor. Feel free to remember this in whichever way you prefer. Take a moment to jot down the method you like when going backward from the image to the pre-image, whether that's dividing by the scale factor or multiplying by the reciprocal of the scale factor. Great job! Now we know the meaning of pre-image and image, and that corresponding sides can be used to find the scale factor. And that we can use the scale factor or its reciprocal to find missing values. Let's try one example problem. This says to determine the scale factor and use it to find the measure of side xy on the pre-image. What should we do first? We need to find the scale factor first. Can you find the lengths of 2 corresponding sides? Side YZ is 60 units on the pre-image and 10 units on the image. Go ahead and determine the scale factor using these corresponding sides. Multiplying 60 times 1/6 gives us 10, so that's the scale factor. Now we can use the scale factor to find the length of side XY on the pre-image. We know side XY is 14 units on the image. So go ahead and work backward to find the length of side XY on the pre-image. Pause the video here and take all the time you need. Since we're going backward from the image to the pre-image, we can either divide by the scale factor or multiply by the reciprocal of the scale factor. That means we can divide 14 by 1/6 or multiply 14 by 6, and we get 84. No matter which approach you prefer for working backward to the pre-image, you will still get the same answer.
Today, we learned that when we're identifying scale factors and calculating missing sides, we should always compare corresponding sides in the pre-image and image. This is because corresponding sides can be compared to show what the size began as and what the size became. Once you're done watching this video and finishing up your guided notes, you can move on to levels 1 through 4 in the online practice. Until next time, keep questioning, keep calculating, and remember, matching up corresponding sides is the key to unlocking the right scale factor every time. See you next time!